Welcome to lecture series EPG Padasala for Computer Science. In this lecture, we will be discussing software testing implementation. Learning objectives: outline the different steps involved in the testing process, discuss the merits and demerits of automated testing, explain the sources for test cases with their advantages and disadvantages, describe alpha and beta site test implementation, and find out their merits and demerits. Major content of this presentation has been prepared from the textbook Software Quality Assurance from Theory to Implementation, authored by Daniel Gellin, Pearson Education Limited, 2004. We are aware that in order to deliver a quality assured software product, rigorous testing is required. Testing should be done by the programmer who codes a module and also by an independent test group. Now, let us discuss the testing process in brief. Planning, design and performance of testing are carried out throughout the software development process. The testing process involves the following steps: determining the test methodology phase, planning the test, test design and test implementation. The same is diagrammatically illustrated. Now, let us discuss each step. Determining the test methodology phase. Testing is done throughout the development process. Testing is divided into phases, beginning in the design phase and ending at the customer's site. The main issues that testing methodology has to address are the appropriate required software quality standard, the software testing strategy. Determining the appropriate software quality standard. Here we are aware that different standards are required for different software applications. The expected damage resulting from failed software impacts standard of software quality. Consider a software that is used to control an aircraft. The quality should be such that the software does not lead to any type of failures. Classification of software failure damages, damages to customers and users. The points we will be discussing are: endangers the safety of human beings, affects an essential organizational function with no system replacement capability available, affects functioning of firmware causing malfunction of an entire system, affects the essential organizational function but a replacement is available, affects proper functioning of software packages for business applications, affects proper functioning of software packages for a private customer, affects functioning of a firmware application but without affecting the entire system, inconvenience to the user but does not prevent accomplishment of the system's capabilities. Here through the slide we have outlined the failures and damages caused to customers and users. Damages to the software developer: financial losses, damages paid for physical injuries, purchase cost reimbursed to customers, damages paid to organizations for malfunctioning of software. Non-quantitative damages expected to affect future sales, substantially reduced current sales. So, the product which you have delivered has malfunctioned, may affect the business of the client for whom you have developed the software product. As stated, you may face the listed financial losses and non-quantitative damages. Now, we will discuss how to determine the software testing strategy. What are the issues that have to be decided? The testing strategy, whether you are going to follow a big bang, bottom up or top down. Big bang strategy is not a practical one. In practice, we follow a top down strategy or bottom up strategy or a combination of top down and bottom up strategy. Next issue that has to be addressed is what parts of the testing plan should be performed according to white box testing model. What parts of the testing plan should be performed according to automated testing model. Decision has to be taken with respect to this. How to plan the tests? Tests need to undertake unit tests, integration tests and system tests. Unit tests deals with small chunks, modules, functions, objects, classes. Integration tests deals with units constituting a subsystem. System tests refer to the entire software package or the system as a whole. Let me outline the questions to be answered. Developers need to consider the following issues before initiating a specific test plan. What to test, which sources to use for test cases, who is to perform the tests, where to perform the tests, when to terminate the tests, what to test. An approach to perfect testing is to recommend a full and comprehensive software test plan that requires performing unit tests for all the individual units, integration tests for all unit integrations, a system test to test the software package as a whole. Let me outline the factors to be considered for unit and integration tests. Which modules need to be unit tested, which integrations should be tested, low priority applications tested in unit testing may not be needed or included in the system tests, and lots of planning is needed as testing is a very expensive undertaking. Let me outline the rating units, integrations and applications. The methods for modules, integrations and applications to determine the priority in the testing plan are based on two factors. Factor A, damage severity level, factor B, software risk level. Damage severity level deals with the severity of results in case the module or application fails. Software risk level deals with the level of risk that represents the probability of failure. Let me outline the issues affecting software risk level. Issues related to modules or application, the size, complexity and difficulty, percentage of original software versus percentage of reused software, programmer issues, professional qualifications, experience with the modules specific subject matter, availability of professional support, acquaintance with the programmer and the ability to evaluate his or her capabilities. Who performs the tests? Unit testing done by the programmer or development team, or both. Integration testing can be the development team or a testing unit. System testing usually done by an independent testing team, internal or external consultants. For small companies, another testing team from another development team can be used and swapped. Where to perform the tests? Unit and integration testing are naturally carried out at the software developer's site. If system testing is to be performed by external testing consultants, a third opinion arises: the consultant site. It can be done in the developer site also when not tests terminated. The stage at which software testing should be terminated is with respect to system tests. 5 alternative routes are available, each chosen on the basis of different criteria: the completed implementation route, the mathematical models application route, the error seeding route, the dual independent testing teams route, termination after resources have petered out. Now, we will discuss each. The completed implementation route. Testing is terminated once the entire test plan has been carried out. Error-free results are achieved for all the required regression tests. This helps in the perfection approach, which disregards budget and timetable constraints. The mathematical models application route. This approach is applied to estimate the percentage of undetected errors. Testing would be terminated once the error detection rate declines below the rate that corresponds to a predetermined level of undetected errors. The disadvantage of this route is that the mathematical model chosen may not fully represent the project's characteristics. The error seeding route. Errors of various types are seeded in the tested software prior to the outset of testing. The percentage of discovered seeded errors will correspond to the percentage of real errors detected. Testing will terminate once the residual percentage of undetected seeded errors reaches a predefined level, which is considered acceptable for passing the system. The dual independent testing teams route. If this route is adapted, 2 teams will be independently carrying out the testing process. By comparing the list of detected errors provided by each team, the number of errors left undetected is estimated. Let me state: NA denotes the number of errors detected by team A, NB denote the number of errors detected by team B. Count of detected errors is arrived by comparing the lists. Number of errors detected by both team A and team B. We would expect to find the proportion of errors detected by team A, the proportion of errors detected by team B, proportion of errors detected by both team A and team B, proportion of errors undetected by both teams, number of errors undetected by both teams, and total number of errors in the software package of program. This approach in fact improves the detection rate. Test design, the planning stage of the software system test, is commonly documented in a software test plan. The test design is carried out on the basis of the software test plan as documented by the software test plan. A template for software test plan, scope of the test, the software package to be tested, name, version and revision, the documents that provide the basis for the plan test, name and version for each document. Testing environment, testing sites, required hardware and firmware configuration, participating organizations, manpower requirements, preparation on and training required for the testing team. Test details for each test, test identification, test objective, cross reference to the relevant design document and the requirement document, test class, test level, whether it is unit test, integration test or system test, test case requirements and data to be recorded. Test schedule for each test or test group includes time estimates for the following: preparation, testing, error correction and regression tests. Software test description, the test procedures and the test case database or file may be documented in a software test procedure document, test case file document or in a single document called the software test description. A template for software test description, scope of the test, the software package to be tested, name, version and revision, the documents providing the basis for the design test, name and version for each document, test environment for each test, test identification, the test details are documented in the STP, detailed description of the operating system and hardware configuration and the required switch settings for the test, instruction for software loading, testing process, instructions for input and data to be recorded during the test cases for each case, test case identification details, input data and system settings, expected intermediate results if applicable, expected results, numerical, message, activation of equipment, etc. Next, actions to be taken in case of program failure, procedures to be applied according to the test results summary. The testing implementation phase activities consists of a series of tests, correction of detected errors and retest. Testing is terminated when the retest results satisfies the developers. Test design phase, software test description, testing, software test report. Next, test summary report. Is the quality of the software acceptable? If it is yes, you end the testing process. If it is no, correction of the detected errors by the software development team, then retesting the software, software test report is prepared, test summary report is prepared and again you check whether the quality of the software is acceptable. This process is repeated until the quality of the software is acceptable. Testing implementation phase activities consists of a series of tests, correction of detected errors and retests. The tests are carried out by running the test cases according to the test procedures. In manual software tests, only a portion of the original test procedure is retested to save testing resources and shorten retesting duration. Now, let us look into a template for the software test report. Test identification, site, schedule and participation. The tested software identification, name, version and revision. The documents providing the basis for the test, name and version for each document, test site. Initiation and concluding times for each testing session, test team members, other participants, hours invested in performing the test. Test environment, hardware and firmware configurations, preparations and training prior to testing. Test results, test identification, test case results for each test case individually. Test case identification, tester identification results, OK or failed. If failed, detailed description of the results or problems. Summary tables for total number of errors, the distribution and types. Summary of current tests, comparison with previous results. Special events and testers proposals, special events and unpredicted responses of the software during testing, problems encountered during testing, proposals for changes in the test environment, corrections in test procedures and test case files. Test case data components. A test case is a documented set of all the data inputs and operating conditions required to run a test item together with the expected results of the run. The tester is expected to run the program for the test item according to the test case documentation. Actual results are then compared. The expected results noted in the documents. When some or all of the results do not agree with the expected results, a potential error is identified. Test case sources. There are two basic sources for test cases: random samples of real life cases. Examples include a sample of urban households to test a new municipal tax information system, a sample of shipping bills to test new billing software. Synthetic test cases does not refer to an existing customer, shipment or product, but to combinations of the system's operating conditions and parameters. Comparison of test data sources. Implication: effort required to prepare a test case file. Random sample of cases, low effort, especially where expected results are available and need not be calculated. Synthetic test cases, high effort, parameters for each test case must be determined and expected results calculated. Implication: required size of test case file. Random sample of cases relatively high, as most cases refer to a simple situations that repeat themselves frequently. Synthetic test cases relatively small, as it may be possible to avoid repetitions of any given combination of parameters. Implication: efforts required to prepare the software tests. Random sample of cases, high efforts, as tests must be carried out for large test case files. Synthetic test cases, low efforts due to relatively small test case file compiled so as to avoid repetitions, implication, effectiveness, probability of error detection, random sample of cases, relatively low unless the test case files are very large, no coverage of erroneous situations, some ability to identify unexpected errors for unlisted situations, synthetic test cases, relatively high due to good coverage by design, good coverage of erroneous situations by test case file design, little possibility of identifying unexpected errors as all tests are designed according to predefined parameters. Automated testing. Automated testing represents an additional step in the integration of computerized tools into the process of software development. Factors that have motivated the development of automated testing tools are anticipated cost savings, shortened test duration, heightened thoroughness of the test performed, improvement of test accuracy, improvement of result reporting, statistical processing and subsequent reporting. Types of automated tests: code auditing, coverage monitoring, functional tests, load tests, test management. Code auditing. This test performs automated qualification testing. The code auditor checks the compliance of code to specified standards and procedures of coding. The auditor's report includes a list of the deviations from the standards and a statistical summary of the findings. Coverage monitoring. Produce reports about the line coverage achieved when implementing a given test case file. The output includes the percentage of lines covered by the test cases as well as listings of uncovered lines. These features make coverage monitoring a vital tool for white box tests. Functional tests. Automated regression tests performed for the whole program verify that the error corrections have been performed satisfactorily. An automated testing tool that supports functional tests, the output comparator will help in the regression test stage. The automated comparison of outputs of successive tests enables testers to prepare an improved analysis of the regression test. For load tests to be performed, the maximum load environment must first be created. Load tests are based on scenarios of the maximal load situations. Virtual users and virtual events are generated and operated in a hardware and communication environment defined for load tests. Test management. Automated test management software provides features applicable for manual as well as automated testing and for automated tests only. The inputs together with the software packages capabilities determines the application's scope. Pros and cons of automated testing. Advantages: accuracy and completeness of performance, accuracy of results, log and summary reports, comprehensiveness of information, few manpower resources required to perform tests, shorter duration of testing, performance of complete regression tests, performance of test classes beyond the scope of manual testing. Disadvantages: high investments required in package purchasing and training, high package development investment costs, high manpower requirements for test preparation, considerable testing areas left uncovered. Alpha and beta testing programs. Alpha site and beta site tests are employed to obtain comments about quality from the package's potential users. Alpha site tests are tests of a new software package that are performed at the developer's site. The errors identified by alpha site tests are expected to include errors that only use by a real user can reveal, and thus should be reported to the developer. Once an advanced version of the software package is available, the developer offers it free of charge to more than one potential user. The users install the package in their sites with the understanding that they will inform the developer of all errors revealed during trials or regular usage. Advantages and disadvantages of beta tests. Advantage: identification of unexpected errors, a wider population in search of errors, low cost. Disadvantage: lack of systematic testing, low quality error reports, difficult to reproduce the test environment, much effort is required to examine reports. To summarize, the main issues to be raised with respect to testing implementation are test effectiveness and efficiency, process of planning and designing tests, sources for test cases, main types of automated software tests with their advantages and disadvantages are discussed. Alpha and beta site test implementation with their advantages and disadvantages are also discussed. I acknowledge the authors of the books which I have referred and the web resources I have used for this presentation. Thank you.